Hi everyone, this time we're going to talk about piecewise defined functions. You should know what these are from algebra, so I'm not going too depth on them, but I do want to remind you about how to graph them and how to evaluate them at different points. So the first thing we're going to do is graph, so let's draw some x and y axes. And there we go. And to remind you, undo. And to remind you of how this works is that we're going to have different conditions. If we look at when x is less than 1, then f of x is going to behave like this linear function 3x plus 2. But if we look at x greater than or equal to 1, then this function should behave like the quadratic x squared. So we'll use that information to draw our graph. So here I'm going to make each 2 squares 1, and we'll see how this works. So and also I'm going to draw in a line here, so let me pick a different color here. And the reason I'm going to draw this line is because this line serves no purpose other than to show you to the left of this line the function is going to look like a line, and to the right of this line is going to look like a quadratic. And that's what the piecewise defined function does, is at these certain points the graph is just going to change in behavior. And this point here, x equals 1, is for this function that change. So let's pick our color. And so our function is 3x plus 2, so the y-intercept is at 0, 2. And then it'll go up 3 over 1, so we'll go 1, 2, 3, and over 1. And then we'll go down 1, down 2, and down 3, and over 1. And here is our line. This dot, though, should be open, though, because this inequality does not have an equal sign. So let's draw this as neatly as we can. Let's see, 1, 2, 3 over 1. So here's another point on the graph. And we keep going on like that. Let's draw that one more time. There you go. So now we want to, so this is this part right here that I've drawn in black. So that is that part of the graph right there. And so now we want to draw the other part here. So let me choose a different color for that part. Actually, you know what? No, because it's the same graph, we should use the same color. Okay, I don't know what I grabbed, but it wasn't the right tool. So let's look at this part right here. X squared is greater, x squared for x greater than or equal to 1. So we're going to start at 1, 1, since we are allowed to evaluate at exactly 1. And notice that the dot is filled in because we have the equality there. So next thing we are going to do is just plot the other points. So here's 2, and we need to get up to 4. So here's 1, 2, 3, 4. So here's the next point here, and our graph is, let's draw a nicer parabola. And there you go. And so this is what this function looks like. We have the linear part to the left of the dashed line, and to the right of the dashed line we have a parabola. And notice that we have this gap in value. So we're jumping from something approaching 4 to a y value of 4 to something that has a y value of 1. So this is how you graph piecewise defined functions. You do not have to draw this dotted line. This is just emphasis for the lecture. So now to evaluate. So let us see if we can copy that real fast. So Shift, Control copy, and we'll bring it down here with us. So let's see, Control V to paste. So here's our function again, and now we want to evaluate at different points. So if we evaluate at anything less than 1, so let's say at -1, well, that says that, well, we check this against these conditions. And which one does it satisfy? So notice that the first statement, it is true, and the second one, it is false. So we use this line here. So this is going to be equal to 3 times -1 plus 2. And when we simplify that, we get a -1. If we take a value that is strictly greater than 1, so for example f of 2, well then that means that we're going to have to use the squaring function. And so this is going to be equal to 2 squared, which is 4. Now what happens if we evaluate at 1? Well, we have to check our inequalities, and we notice that the first one, it is false, because equality is not allowed in this one, but equality is allowed in the second one. So we end up using the second line again, and we get that 1 squared equals 1. So just remember that to evaluate, you just first have to run through all the conditions to see which one is true, and only one of them should be true. You should not get more than one line to be true. If you do, there's something wrong with your piecewise defined function. You've got to go back and look at it. So that's piecewise defined functions, and this is the end of the third section. So we'll move on to the fourth section in the book, which will talk about translation. So that'll be the subject of the next videos. See you then.